Hello everyone, my name is Abhishek Sharma. I am the member of Group 1 and here I am presenting for the term project of CHE 201. These are the topics that we are going to cover in our presentation. So the first topic is the introduction of reactor, in which we will see the type of reactor kinetics, reactions related to the reactors and the molar balances inside the reactors. These are the different types of reactor that we will see in the upcoming slides. So what is a reactor? Reactor is the equipment in which reaction is carrying out and it is converting reactant into product. If reaction is not taking place inside a tank, that we cannot say it is a reactor. Example, transportation system is not an example of reactor. So the main purpose of the designing a reactor is to maximize the profit inside the industry. We can do it by achieving highest efficiency and yield of the reactions that is taking part in the reactor. And we also want to minimize the capital and operation cost. Why do we even need a reactor? So reactor is a device which convert low value material into high value product. So it also provides a dedicated and controlled reaction zone in which we can do the reaction very safely and in an efficient manner. It also optimizes the variables like temperature, pressure, and flow rate, and that are optimal for a reaction. These are the classification of reactors. So on the basis of operation type, there are three types of reactors: batch reactor, semi-batch reactor, continuous reactor. On the basis of phase, there are two types of reactor: homogeneous reactor and heterogeneous reactor. And on the basis of catalyst presence, there are two types of reactor: catalyst and non-catalytic. These are the pictorial view of different type of reactor. So first we can see the batch reactor. Second one is the semi-batch reactor. Third one is the CSTR tanks. Fourth one is the plug flow reactor, and fifth one is the packed reactor. We will see about these reactors in further slides. So these are the real pictorial view of the reactors. We can see the industrial reactors, lab scale reactors, and micro scale reactors as well.
And I'll continue from here. So this is a batch reactor. This fan type thing you can see is a catalyst which helps speed up the reaction. This batch reactor is a closed system where you put all the reactants at the start and let them react. The concentration decreases with time. And this is the mole balance equation, which is generation equals to accumulation, which we have shown here. We have calculated the time needed to reach a certain conversion XA here. And as you can see, this is an integral in integral form. So this is because the RA is not constant here. It depends upon the concentration. Moving on, we have continuous stirred tank reactor, which is also known as CSTR. In this, the concentration is uniform everywhere and it is identical to the exit concentration. And the reactants flow in and the products flow out continuously, so they are perfectly mixed. Here we have shown the design equation at steady state, which is in minus out plus generation is equals to 0. And we have calculated the volume needed for a certain conversion XA. Here you can see that this is an algebraic equation. This is because the RA is constant here throughout the reactor. Moving on, we have plug flow reactor, which this looks like a long tube in which reactants flow throughout and they don't mix in the direction of the flow. The concentration is highest at the inlet and decreases with position like along the length in the reactor. And this is the design equation which we have formed. This is formed by taking small slices of the long tube. So we have calculated the volume we need for a certain conversion XA. Here we also see that we have got in the equation in an integral form. This is because the rate law is dependent upon the concentration and it depends upon the concentration depends upon the position. Okay. So here we have differentiated the reactors we just studied. So in batch and PFR, we just saw that the rate law is not constant, whereas in CSTR, the rate law is constant. And we have seen the design equation of CSTR is algebraic, whereas for batch and PFR, it was integral. And the concentration in batch changes with time. In PFR, it changes with volume. But in CSTR, we know that it doesn't change. Here is a further comparison deep down. So the batch reactor is unsteady, like the operation method is unsteady, and CSTR and PFR are both steady. Batch reactor is closed. CSTR and PFR, we know that the reactants flow throughout. And in batch reactor, the mixing is complete. In CSTR also, the mixing is complete. But PFR, the mixing is only radially. It doesn't mix in the direction of the flow. We just discussed that. And the conversion varies with time in batch reactor. CSTR, we have a constant composition because of a constant concentration and rate law. And in PFR, it varies with length.
Continue with the advantages and disadvantages of the reactors. So the advantages of the batch reactors is that they are good for small scale reactions. We can achieve high conversion rate in batch reactors and they are simple to clean. These are some disadvantages of the batch reactor, that a lot of manual work for loading and unloading and cleaning. And other than that, they provide poor heat control at a scale. So it is difficult to manage temperature for highly exothermic reactions. So these are the advantages of CSTR. They are excellent in controlling temperature. So we can do exothermic reaction easily in these types of reactors, and we can get good mixing in these types of reactors. And they are stable and continuous operational. So we can control and automate for steady production in the CSTR. These are the disadvantages of continuous stir tank reactor. They provide low conversion per volume, and other advantage is back mixing. The product get mixed with the reactant after the reaction, and they are very large in size, so it is difficult to operate them. These are the advantages of plug flow reactor. The main advantage is that it provides highest conversion per volume. other than other reactors like CSTR and batch reactor. This can take place in these types of reactor. These are the disadvantage of plug flow reactor, that it do not control temperature efficiently because there are some hot spots in plug flow reactors, and it is very difficult to clean the plug flow reactor, and they are very inflexible, not for slow reactions. It is a conclusion that we define chemical reactors and their classification, understood lab and micro scale reactors, and learned basis and molar balances about their rate of reaction, and paired advantages and disadvantages of the batch and CSTR.
Today we are going to know about the CSTR, the continuous return reactor. So in this type of reactor, all the reactants flow continuously into a tank, whatever the reactor we have, and everything is uniformly mixed. And and the reaction is taking place at the same time while the product is getting out of the reactor. So as you can see, this one here is the inlet. This pipe is the inlet, and this is the outlet. While everything is happening inside the water purifier, like there is active charcoal or UV light that is purifying the impure water that is entering through the inlet and exiting through the outlet. And the wastewater is eventually getting out of an extra outlet into the dump water. We are going to learn about the batch reactor today. So we are going to learn it through making Maggi. So what we are going to do is, in batch reactor, we put all of our reactant into the reactor. That is our pot here today, and we close the reactor and all the chemical reaction happens inside the reactor, and after the reaction we take out our product. So here's what we are gonna do today. First of all, we are gonna heat up our water. So next we are gonna put our Maggi inside the boiling water, okay, and also the spices that we get with the Maggi. Just stir it up a bit so that all the spices and the Maggi get mixed up with the water inside. We put a lid on the top of a pot and let it cook for about a minute or two. So it's about 2 minutes, and now we will open the lid, and our Maggi is finally ready, and we are going to put it into a vessel and eat it. Okay. So that was it. That's a simple batch reactor.
So reactor is a system where the fluid moves continuously through the flow, and as it moves, it reacts with the elements inside the system. A water geyser works in a similar way, where the inlet cold water goes into the water geyser, where it reacts with this exchanges heat with the heating element of the geyser, and as it flows pass through the heating element, its temperature increases more and more, and we get a hot water outlet and the pipe.